Hello and welcome to our Voices in Montessori podcast, brought to you by the Greenspring Center for Lifelong Learning. As Dr. Montessori told us, an education capable of saving humanity is no small undertaking. We agree, so let's get to work. I'm Tamara Sheesley Balis, and in today's episode, we're talking about the connection between concrete and abstraction in upper elementary and adolescent mathematics. I am absolutely delighted to have Mike Waski here with me today. Mike is a mathematician through and through. I have to share with you. We actually brought him in at Greenspring Montessori to do a parent ed night and knocked all of our socks off. Mike holds both adolescent and elementary diplomas in AMI. He also completed the NAMTA orientation to adolescent studies in 2005. Mike's taught in private, public, and charter schools for over 20 years, both Montessori and non-Montessori, covering grades 2 through 12. In 2018, Mike became the director of the Math Institute. He went to graduate school for math and then fell in love with Montessori, and we're so grateful because now we get him. So welcome, Mike. Thank you so much for being here with us today.
Oh, no, thank you. Thank you so much for having me and for asking me to do this and to share a little bit about mathematics with everyone. So I appreciate it very much.
We're so happy to have you here. And this is your first podcast.
It is. It is. First time doing this.
I can't believe that we have somebody of your caliber in the math Montessori world, and it's your first podcast. So I feel so grateful to get to have you on. So let's get started.
Okay.
All right. So let's start out by talking about the challenges that you're seeing in creating an engaging and inspiring math curriculum for upper elementary students specifically, and does the same go for the adolescents?
Yeah, I think one of the things that I hear from some upper L teachers is that, well, they've already finished what's in the album and there's nothing more to do. But really, I think there's just still so much more for them to do. I think there's lots of extensions, there's lots of work for them to be doing. And to really challenge the students to be creative. I mean, it's not so much about giving lessons. I mean, it is about giving lessons. You want to give them the lessons, but it's what they do with that work that's really important. And so I think there's always more for them to be doing, to take what they've learned and just applying it in different ways. And I think that's a thing for adolescents especially, but even for the upper L folks, is that, can they take what they've done and apply it? Can they really use the mathematics? So if they're, studying something in science class, can they then take the math that they've learned in the math class and use it in their science class or in their history class or just in their communities? Are there things that they can apply math and really see the use for it? And I think that's the one thing, the one question I hate to get when I work with adolescents is, when am I ever going to use this? That's a question a lot of people ask. And my goal always has been that kids should never have to ask that question, because they're always seeing the use for mathematics. They're always seeing why they're using it, because they're like that's the impetus for learning math is a practical application. Okay, we have a problem to solve, we have a task to accomplish. We're going to use mathematics as a tool to do that, and therefore they kind of know why they're learning it, and hopefully they're the ones who are asking the questions. So it's not like, let me give you this just in case you're going to need this one day. But it's like the kids are working and they're like, hey, I have a problem I have to solve. I need help with this. Can you show me how to do this? And that's when you can come in with a really good lesson on a topic or whatever. So
Can you give us some examples? So I think it'd be really helpful for people to think about, first of all, you mentioned science. So give us an example of a science lesson that a student may have an issue that then they could solve with math.
Sure. So something just like anytime they're collecting data, conducting real experiments, they can collect data, they can then graph the data, and then they can analyze the data. And so really students should be working with things like slope and intercept and rates of change. They can be doing that in upper L or, definitely in early adolescence. So they're collecting data on, say, burning a candle, and you're measuring the height at different times, and kids collect the data, they graph it, and they see, oh, it's a constant rate. Okay, great. So then what is the rate? They can look at the graph and analyze that. And then when they get to later, we can formalize that as the idea of slope, but they already understand that it's a rate of change. And I remember my math, doing math in high school or middle school with algebra and not really understanding a connection to things. It's like, okay, great. It's slope, but what does that really mean? And then they ask you a story problem and you're like, well, how do I take what I just did and apply it to the story problem? Here, it's kind of doing it reverse. Kids have real experiences doing experiments, and hopefully they'll be creating their own experiments as well. They're like, what other things do you see that have linear rates? Or can you go and test things? I had kids who do things like they'll look at the water meters in their house or whatever, and keep track of how often that's going up, and they'll collect data from that. And sometimes it's linear and sometimes it's not. And so, okay, but they can recognize when a linear equation is happening. And then of course, we don't have to do it right away, but if kids are used to seeing that, they can then take that and write an equation for that. So how could you predict what's going to happen? So, okay, you burned this candle. What if you had a candle that was 10 feet tall, burn at the same rate? What would it do? And then the equation is really just a description of the idea of what's happening. And I think that's what's really important, is that you have to have the concept first. So you can just look at it and say, well, it's going down at 2 millimeters per minute or whatever. Okay, great. Then we can say, well, how, almost like checking and guessing, okay, what would it be in 10 hours or 10 minutes, whatever. And it could say, oh, it's 10 times 2, that's 20, so it's going to be 20 less. So what are you doing? And that's always the question. I always start with something real and then say, okay, so what is it that you're doing? Okay, well, I'm taking whatever minutes you give me and I'm multiplying it by 2 and subtracting it. Great. Subtracting it from what? From the amount that you're starting with. Okay, so then the amount you're starting with becomes the y-intercept, because that's where you're starting. And the kids have experience graphing this. And then it goes down to every minute. But before we put it in a formal equation, or before we do that, kids have done it. They've thought about it. And so then the equation, we're just giving them the language and the formalization of the work that they've already done. So often I think math is done the other way, where it's like, okay, here's this abstract idea. Go ahead and practice it a whole bunch of times till you get it. And now let's try to figure out a way to apply it. I really think the Montessori approach is the opposite way, where it's like, hey, we're doing real work now. And then my job is to just give students things they can't get themselves. Like students can figure out how slope works and how the intercept is. Because it should be a natural thing. But I can then give them that formal language. But if kids don't have those experiences first, then it's just not going to be. It's always going to be a struggle for them, and we don't have to do it that way. Kids don't have to struggle with math. I mean, some things are going to be more difficult, but and some kids might need more time, and some kids might need more help through that. Sometimes kids just get it on their own. They do it, and they're like, "Oh, I see it." Other times kids don't right away. And so our role as the adult is to ask them leading questions. Like I love that question of like, okay, you've done this a bunch of times. Now tell me what you're doing. Describe what you're doing. And then taking them beyond the limits of the materials. Can you imagine what would happen if, getting them to really abstract what they've been doing. And that word abstract means to draw from. Well, if you don't have anything from which to draw, then you really can't be an abstraction. So I think starting with the materials or starting with practical work first, depending on what age group you're in and what the lesson is, I always try to start with something real, whether it's a physical material or a real life scenario, something kids can do and be active in. And then as they understand how it works, then we can bring in the formalization, we can bring in that abstraction later on. So that's my approach, and that's the approach that Montessori talks about. And it really does work. That's the most amazing thing. It's really amazing when you see kids go through that and see them just able to do things. I mean, I'm jealous because that's not how my math experience was. And I know for most adults, that's not what their math experience was.
Right.
And I kind of fell into it backwards because I could not get math at all when I was in high school. And I always had to come up with like tricks and things like that to help me figure it out. Or to remember it for tests and things. Well, what I realized that I was figuring out was the actual way it works, so and that's why I want to share that with other people. I've always been interested in education, but when I kind of fell into the math part of it, it's like, okay, it doesn't have to be a struggle for everybody. And then when I found Montessori, it's just like, blows your mind. It's like, oh my gosh, there's there's already all this out there that's been developed. And it's just a matter of how do we then help others, with that? Because one thing we tend to do, I think a lot, is fall back on our own experiences and what we know best. And so like, if we've had an awful math experience in high school or middle school or whatever, like that's what we don't know there's something else better than that out there, And I think I hear that from a lot of teachers, where even in Upper L, where they're like, well, in middle school, they're going to be using textbooks. So we're going to start using textbooks now to get them ready for middle school. It's like, the way to get them ready for middle school is to give them those experiences now at the appropriate time. And the same thing for middle school. They should be experimenting and doing things hands-on, because that's who they are. That's what, that's the characteristics of the adolescent. That's what they need. Even if they're going to a high school where it's going to be more traditional, my kids do just fine, because they've had those real experiences. They might find it a little boring or a little tedious, but like, we don't want to, we want to do what's appropriate for that age group, regardless of, and the best way to prepare them for the next stage is to do what's best for the current age group that they're in. It's not to bring down what's above now. That's not the right way to do it. And I think a lot of people get caught in that trap. So yeah, I just encourage them not to. And then, hopefully through the work that I'm doing and others are doing, middle school won't be just textbooks, and high school won't be just textbooks. It'll be hands-on. It'll be project-based. It'll be these experiences, and we won't have to feel that pressure, to get them ready for the standardized tests. I mean, standardized tests, we do some prep for that at all the levels, but it's more practical taking skills, not the math. Like the math we always do through the Montessori approach. Because when it comes to the test, a lot of times kids don't realize that, oh, wait, I do know how to answer this question. Or, oh, the language they're using on the test is a little different. So I know here in Ohio, Montessori uses the term units. On the test, they see ones. They call them ones. So just for kids to have that experience of, oh, you're going to see ones, that just means units. To prepare them for that, how do you take a multiple choice test? You know the math, because you've done the math the right way, but it's like, how do you then translate that to what the test is going to demand? So we'd always spend some time doing that, but I looked at that as practical life, not teaching to the test. We teach them math, and then we help them prepare for the test as a separate skill. And I think that's important that we do that, because we don't want our constituents to say, well, this Montessori sounds great, but they're failing all their exams, or they're not getting, because then they're going to say this doesn't work. It's like, it does work. We just need to help bridge that and do it in an appropriate way. And that's, I found that to be really effective.
And just, can you give us some insight on the skills that you're really looking for children to come up through lower L with, to be prepared to start to move into abstraction and really these taking their concrete and transitioning it?
Yeah. It's to me, it's really not about, okay, the most important thing is that they can think mathematically. Even if they don't have certain skills, like if they don't know positive and negative integers by the time, I know it can be taught in elementary, but if they don't have that when they get to adolescence, I'm okay with that. I can teach that, then I can teach them any skills. But if we're talking skills-based thing, I think fractions, like for them to really, and to not just know the algorithm, but to understand what a fraction is. I mean, I don't care if I'd rather have them spend 3 years in elementary working on fractions than having them get to the more advanced stuff to prepare them for middle school. Because that's something that I find myself teaching over and over again. And a lot of adolescent teachers do. It's fractions, it's decimals, it's that number sense thing. And I think what tends to happen is that there is pressure now in elementary to get them, advanced and get them ready for tests and all those kinds of things. And we don't allow students to just explore with the materials, to be with the materials, to do the discovery for themselves. We tend to push them along. There's a right way to move them along. And then there's, okay, you've worked the materials for a couple days. Now here's the algorithm. Here's multiply the numerator and the denominator by the same number. And then when they get all these rules, they just get them mixed up. They forget them. It might take a long, it's like it might take a long time for them to really understand what a fraction is, and for them to really understand the idea of equivalencies and why they have to get common denominators and when they need to do those things. But if they really understand that, like, that makes things so much easier for later on, because in adolescence, they are not interested in working with those insets anymore. That time is past. So we have to take the appropriate, use the time then when they're interested in that, when they'll sit and they'll just work for hours and hours, with with a big problem or whatever it is that they do. We need to take advantage of that and allow them to explore and to kind of do that kind of work, because that time is going to be past. And then when there's kids in middle school who don't know fractions, they're, like, gosh, I've been doing this for 4 years already, 5 years. I must not be good at math. And they have this negative self-talk, especially for adolescents. Like, that's something that's really the most harmful, is they just think, I'm not good at math. I'm not a math person. They get that from their parents sometimes, where their parents are like, well, I wasn't good at math. My kid isn't good at math. Like, you don't inherit that, it's about your experiences. And so, I think the fractions, like the decimal work, to have students really understand that the decimal system is really important. To me, those are just the biggest things that stand out right away. And then whatever they do, whatever that you are teaching them, that they really do understand. So like, in geometry, area of a triangle, 1/2 base times height. That they can discover that for themselves. There's the yellow material. They can work with that. They can manipulate that. They can write the equation. Giving them enough time to discover that for themselves is just so important, because when you figure it out for yourself, you understand it in a deeper way than just being given it. Like, my math was, here's the equation, do it 50 times till it's drilled in your head, and then you won't forget it. Like, that doesn't work. But even if you spend just as long, figuring it out, the impact is going to be much longer lasting. It's going to be deeper, and then you don't have to keep reteaching it. And that's what I find is, like, as kids get older, you're reteaching the same thing over and over again because it wasn't done in the proper way the first time. And that's frustrating for the students. It's frustrating for the adult, because, I don't have, the reason that stuff is taught early on is because that's the appropriate age to teach that. It's much more difficult to teach it, even though the kids might be smarter, or they've had more math experience. Teaching them fractions in middle school is really tough for a lot of reasons. One is because they don't want to do it anymore. And secondly, it's because they're not going to work in the same way. They're not going to take that time to match the equivalencies and do that work that's really foundational. I had that experience with my own niece. She failed her first math test. I think it was like 5th or 6th grade or something. And I went over to help her, and it was fractions. And the test was doing all kinds of things on there with mixed numbers and adding and subtracting and all that. And so, I said, well, what's bigger, a third or a half? And she wasn't sure. That was the issue. It's that she didn't understand, like, the concept of fractions. And for me to help her in an hour, I can't get her ready for this test. I said, the time is past. Like, you gotta work on this for a long time to really understand it. And and the same is true for the work in the adolescents, is that it's better to take more time with the fundamental concept, whatever those keys are. Even though it feels like you're going slower, the learning will accelerate later on. And you have to trust that process. It really does happen. When I'm teaching with the high schoolers, if they don't understand slope and slope intercept and all that kind of stuff, when they get to calculus, like, all derivatives it's slope. It's the definition of slope. But if they don't understand what slope is, then half the time in calculus, I'm spending time reviewing the algebra stuff because they didn't have the right foundation. Same thing, I'll ask the kids, have you learned the quadratic formula? 7th graders, whatever. Oh, or 8th graders. And they're like, and they'll sing a song and they'll spout out the formula, but they have no idea what it's used for. It's like, so we take our time, we go through the factoring, we use the materials, and kids can figure out pretty much the quadratic formula on their own and derive it. And even if they forget how it's derived, they understand what it's used for. Like, okay, it's there to solve a quadratic equation that can't be factored, because they've had that experience, and it takes longer to get there. But then once they're there, then we can do all kinds of things much more quickly later on. And I think that's what's really important. So yeah, I would just say whatever skills the kids are doing, whatever's in your album for Upper L, just do it really well, and don't be afraid to take your time with it. There's just this rush, I think, to get to the advanced work as quickly as possible. And that's like how good of a teacher you are, how smart the kids are. Like, no, just learn it really well. Whatever you're teaching, just have the kids, have it become a part of them, have them discover it for themselves as much as possible. And whatever they know, I just want them to really know. To me, that's what I always tell teachers. Whatever they know, I want them to really know. I could always backfill skills later if I have to, but the worst thing is for them to half know something, to kind of know it. And so I'll just give a quick example. When I was teaching in the high school, I had freshman year, we were doing an activity where students were to simplify square roots. So it's not the same thing that's done in elementary where they extract it, figure out the square root of the decimal, but it's taking something like the square root of 8 and writing it as 2 times the square root of 2, just simplifying that down. And I have a material for that, and there's lessons on it in the book. And I showed it to the students, and like, okay, great. They watched the lesson, and they were going to go off and they're going to do a page of practice on that with the materials. I got an email that night from a student who said that I didn't really get it. Can I ask you some questions tomorrow? I said, sure, absolutely. So we sat down, and it was something like, okay, the square root of 18. And I said, is the square root of 18 a perfect square? She says, yes. Okay, we'll try to make a square out of the 18. She says, oh, no, it's not. I'm like, okay, can you make smaller size squares out of those 18? No, I don't think so. Well, go ahead and try. And I can make 2 squares of 9. And then she did that. So we tried it again and did a couple of examples. And see, for her, the key was she didn't really know her squares and didn't understand that. But, so we struggled through a few of them, and I said, okay, I'm going to work with some other students. Do you understand it now? She, yeah, I'll work on my own. By the end of class, she had the whole page done. And it was all right. And I'm like, how did you do that? She goes, oh, well, I just made a list of squares, and I just divided the numbers by the perfect squares. She figured out the algorithm. That's usually what happens is like, that's, if you learned it the traditional way, it's like, see the square, divide by the square number, and move these things here. She figured it out on her own through the materials. So that was really great.
That's the thinking that you're underscoring.
Exactly. That's it. Yeah. She's thinking it through, and then she made the discovery on her own. So the next year, her sophomore year, we're doing in geometry class, whatever, the Pythagorean theorem. I said, make sure you simplify your square roots. Because I don't know what that means. Okay, let me go get the material. I got the material from the shelf. We did one example together. She's like, oh, that's the thing where you have the squares. Like, yes, that's right. And then, but because it just recalled what she did before. I didn't have to reteach the whole thing. It was just a quick reminder. Junior year, we're doing the quadratic formula. Make sure you simplify your square roots. She goes, I don't know what that is. I'm like, let me get the material. And as soon as I said that, she goes, wait a minute, is that the thing where you have the squares and you have to divide? I'm like, yep, that's what it is. She's like, okay, I know how to do that. So it took a long time in the beginning, but the recall got quicker and quicker for that, because it was something she discovered for herself. It was a part of her, and it was done practically. It was a hands-on thing. And I see kids, even in high school, like drawing things out sometimes when they're completing the square. The conversation won't be, oh, make sure you divide by 2. It's like, oh, remember you have 2 squares. Oh, that's right. I hear those conversations, relating it to something physical and practical. And also slows them down. It makes them, they have to take their time a little bit. And during that time, it's not a waste of time. It's where they're thinking, they're processing, and that's a really important time. And that's especially true in elementary, where we need to give them enough time to just sit and think. And, it might seem like it's wasting time, but really it's that slow, careful work that Montessori talks about. We have to honor that. And I know it's hard in this world today to give them the time to just be and explore with the materials, but it's so critical. And I promise it pays off in the end. It pays off in the end.
I do have a question about that because it's a beautiful concept. And part of what I know the challenges that some guides face are students coming up and saying, I don't want to work with materials anymore. I've already done that. Why do I need to go back to that kind of thing? Can you talk about that a little bit?
Yeah. Kids will work with materials if they're done in an appropriate way. And so I'll give an example. So at the high school, we were doing factoring, different ways to factor, and we used the algebra tiles. So I gave everybody the lesson with the algebra tiles, and then had the students work with them. And then as soon as they were ready, as soon as they could work with abstraction, they could do abstraction, no problem. Because that's the idea, right? I mean, you don't want them to work with the materials forever. Some kids spend a long time with the materials. I had one kid who just did not want to use the materials at all. And so he just did all of the work in abstraction. So, which is fine. And he got it. He was able to do it. The final project they had to do, they had a choice. And one of the projects, I had some advanced projects for kids who could do that, doing different applications of it. But one of the projects was to show how it's done with the materials. Well, this kid, he's good at math, but he wasn't the hardest worker necessarily. So he's always looking for the kind of the easy way out. He didn't want to spend the time with the materials. He just wanted to get it done. So he's like, well, I'll just pick the easy project. I'll just do the materials demonstration. And so he already knew how to do everything in abstraction. But when he started to do with the materials, he was like, hey, wait a minute, how do you do it with the negative? Or when you're completing the square, like, how do you do it with two squares? He knew how to do it abstractly, but he's trying to figure out how to do it concretely. And so he understood it in a totally different way. And he made this really great film. He did stop motion animation to show how all the different factorings worked. And it was a really amazing project from a kid who did not want to work with materials to see him work with the materials, And so as much as possible, I try, for the adolescents especially, we repurpose the materials. We use them in different ways. So I have behind me there the powers of 3 material and the powers of 2 material, and we use those for negative exponents and fractional exponents. And we have several materials for those, and I'll demonstrate it to the kids, but at least if they see it, I'm going to give the initial lesson with that. They understand that there's a purpose there. They understand how it works. And if they go to abstraction pretty quickly, I don't have a real problem with that, especially in the adolescents, as long as they really do understand it. But what I find, though, is, kids will say, oh, I got it. They do the work abstractly. Then they come to something they don't know how to do. And it's like, okay. Or they're doing something totally wrong. That's why I say, let's go back to the materials. Let's see what's actually happening. And then they can work with the materials. Oh, okay, I see what's going on. Then they go back to the abstract work. And so adolescents especially, they'll often work concrete to abstract. They'll go back and forth a lot more. Where I think a lot of times the elementary kids will do concrete, then they go into abstraction. They kind of abandon the materials. I think it's really important, especially for the adolescents, and I guess for the upper L folks too, is to, present with the materials regardless. And then allow the students to choose whether to use the materials or not. But if they can't do it abstractly, at least they've had the introduction to the materials. They know that it exists. And I always call them back to the materials when there's a misunderstanding. And I think that's really important, because if I don't give that initial lesson with the materials, then there's nothing to fall back on, And oftentimes it's just getting them to look at it again. Oh, I see how it works. Then they can go back to their abstraction. So I don't force kids to use materials. I'm thinking mainly adolescent students. I don't force them to use the materials, but I always present with the materials. They're always available on the shelf for them to grab when they need them. But I do also always refer back to the materials when they struggle with something, because I think that's really important that they see what they're doing. They're making that connection between the concrete and the abstract, because some kids really can. I mean, you can give them one demonstration and they're like, okay, I get it now, which is fine. And I'm not going to, and if I force them to use materials, that's just going to kill their spirit. They're going to be like, why am I doing this? That's just as bad as giving them 50 problems to do and have them do rote work. If they really don't need the materials, but through their work, they should see that. And so what I'll also do is I won't give them. So in like the books, I have a whole bunch of lessons, but I won't give all those
I just
lessons to
want
all
to
the
pause
kids.
you for 1 second because
Yeah.
we didn't talk about your book. So
Oh,
we should talk about your book. So people know what you're referring to.
okay.
Mike actually wrote the Montessori book. Can you talk a little bit about your book and then we'll circle back to that so people know what you're referring to?
Yeah. So I basically took a compilation of the lessons that I would give for adolescents, and I tied them to the work of the elementary. So it's kind of like a bridge. It's like taking off what kids have done the elementary and expanding that, and then going into that. So I have an algebra book. Well, it's actually now it's split into 2 volumes. Some people might have the old one where it's just one giant thing printed off of my computer. Teaching teaching algebra to the adolescent, volume 1 and volume 2. And I have a teaching geometry to the adolescent book, which is also available. And I just finished writing teaching arithmetic to the adolescent. And that's being proofread right now, and that should be available in the fall. And that's really like, okay, you have kids who don't know fractions. How can we then help them? And it's not as much materials based, this book is, but it's more about like, how do you present things to students, the arithmetic parts, and then it goes into probability statistics and those kinds of things. So that's coming pretty soon. But basically, it's just a lesson. It's like it's a dialogue that we'd have with the students. And it really covers pretty much everything that I've ever taught in for my adolescent work. So that's what I'm referring to with
That's perfect.
with
And we will drop in the show notes. So make sure we have it too, Mike, where to get Mike's book so that you all can just click on the link and have access to his books. Okay.
Thank you so much for that. Yeah, no, I mean, it's always strange, like me putting that out there. I'm always like, oh gosh, this is my stuff. Is anybody going to like it? But people have said it's been really helpful, and I've done workshops on it. And actually, for the Algebra 1 book, I did every lesson in video form. So there's videos available for every lesson now. Yeah, we just did that because I would do workshops with that, but there's something about reading it, and that's something about but doing the videos, and I could take my time. I could talk about it a little bit more, maybe add some things that aren't in the book. So we're thinking about doing it for the geometry and for the advanced algebra, but that might come out sometime down the road.
We have to use technology as we've got to make it our friend here, because the truth is it's impacting us so much negatively. I think we have to take every positive avenue for it possible. So, and I want to get you back to talking. You were talking about having the students really be able to move between abstraction and concrete in adolescence, and what you referred to in the book. So I'm going to bring you to that strand. Yeah.
Yeah. Thanks. So like I would give them the key lesson with the algebra tiles, which might be like the variation A. And then the other variations, I'm not going to teach them that. What I'm going to do is I'm going to show them how the materials work. But then when students get to that, if they don't know how to do it, then they can either figure it out for themselves, or I could teach a lesson. I could give them lesson on how then you do it with negatives, or how you do it with multiple factors, or whatever it is. But as much as possible, though, I try to give the kids the key lesson, minimize the time I'm presenting, give them what's essential, and then let the students work and explore. But I'm always prepared to jump in with a lesson, to give them that extra help, to refer them back to the materials or whatever. So my role, except for those initial lessons that I give, pretty much I try to run my classroom like a math lab where kids are just working. It almost looks like an elementary classroom where kids are just working on things. They're all working on math if they're in the math class, but they're working on math, kind of going at their own pace. And I'm ready to jump in and give help and guidance when needed. I found that to be really effective, because then kids, in a traditional classroom, I feel like half the kids are bored because they can be going faster, and then half the kids are lost because you're just pushing them through. And, if you have the materials, then that they become the teacher. That's what Montessori talks about in the elementary. So I'd do the same thing for the adolescent work. Have the materials be there for the students. They can go as quickly or as slowly as they need to go, and then I can just kind of guide them through and give help when needed. So I'm not giving too much help, and I'm not abandoning them either. So that's kind of my goal.
I think that's so important. And I think that our guides, our Montessori teachers, would love to know from you what the essential components are to include for students to make sure they're hitting those high notes in the mathematics curriculum. Can you speak to that?
Yeah, I mean, well, yeah, I mean, there's definitely keys for the adolescent, like things like the idea of an inverse. You know, if you understand how an inverse works, that everything can be undone, everything has it, and that starts in elementary with addition and subtraction being inverses and multiplication and division. But as it progresses, you know, and we start solving equations, basically all solving an equation is using the inverse and using the inverse order of operations. So if kids know that really well, then when we get to something like, okay, we're doing logarithms, how do you solve a logarithmic equation? Well, guess what? There's an inverse. And once you know the name of that inverse, you're solving a trigonometric equation. Hey, sine, what's the inverse of sine? It's sine inverse. Okay, great. Let's use that. You know, so if they understand that key concept of inverses early on, then then, you know, it saves so much time later, because every time there's a new type of equation to solve, I don't have to start from the beginning and talk about how to solve it. It's just like, we're going to use that same concept again. Here's the one new term, and we're just going to go from there. So I think, you know, I think the idea that we can represent things geometrically, I think is really important, and that starts in elementary with, you know, equations of like their area formulas and things like that. That, okay, there's an algebraic way to solve it, but yet we can see it in geometric form. We use that a ton in for the adolescent work, for all the factoring work and completing the square and all that kind of advanced stuff. It's like things have a geometric form, and that goes back to the math history. I mean, that's how the algebra started in geometry. I mean, there's a lot of algebra in Euclid, actually, which is pretty amazing, because that's how they saw things. They didn't have a base 10 number system then. Oh. And so to solve problems, it was easier to see it, to do it geometrically. So I also share that you mentioned before about kids who don't want to do materials. You know, I tied into history a lot of time and said, this is not something that it's because you're stupid, that's why you need the materials. It's because this is foundationally how human beings see mathematics, and tying it into the history really helps that. So I try to do a history approach to a lot of what we do as well, telling the stories. It's not just a bunch of people sitting in a room writing textbooks for you. You know, it's like there's people and their stories, and we do a lot of the storytelling. And you know, that appeals to different types of students, I think. You know, all my kids are not going to go on to be mathematicians. There's a lot of kids who love the humanities more and and that's how I got into mathematics when I was really little, watching Cosmos, Carl Sagan. You know, he's telling stories, and I just love it. And I get a lot of requests from kids that, hey, can you tell that story again of Pythagoras or of whatever happened there? Because it's just really fascinating. And so I always try to give, so the things I always want to give my students, that I feel I need to, are any materials, definitions and terminology that they're going to need, and any history. So those are things you can't get for yourself. But once you know those, then you can really discover, it's possible to discover a lot on your own. But if you don't know what something is called, it's really hard to do. You can't just say, I think this is called, you know, kids can't just come up with that on their own. Or how do you physically use the materials? Like, I need to give them those things. So I try to limit myself to that, and then just giving them the essentials of the lesson. So if there's going to be like 5 variations, like I give them the first variation, and that's it. So if they're doing things like their area formulas, even in middle school or whatever, you know, I'll give them the yellow material. I'll do the material in a similar way. The triangle, the parallelogram, and the rectangle. Like, the idea is that you reform things into rectangles. Well, once I've done that, then they can figure out the trapezoid on their own, you know, or I might give them a guide where they can kind of manipulate things and step by step on how to figure out the formula, because it's the same concept. For the and then for the polygons, you know, hey, how can you make this into a parallelogram or into a rectangle? And then the circle, kind of the pinnacle of all that, you know, that you can make it into a rectangle. So the key idea is we're going to take a shape, cut it up, and make it into something we do know the formula of, and then teach them how to, or show them how to then go through the thinking process of how do you then figure out what the height is and the width. It's going to be different for every shape, but the way you do it is the same. And so that's really what I find my role is: show them how to do it in a simple case. And then as much as they can they go ahead and discover the rest on their own? Or how far can they go? And then, I'll observe them. And if they're, if kids are working with materials for a really long time, they might need some help in, some guided questions to help them move beyond that. Or if kids are stuck and they can't figure something out, then I'm ready to give them a lesson. But whenever I'm giving them a lesson, I'm not just telling them the answer. I'm taking them through that process, asking them questions. Okay, so what would you do? What did you do? So if they can't figure out the trapezoid, I said, okay, what did you do for the parallelogram? Okay, well, here's what I did. Okay, so can you do the same thing here? So I'm getting them. I think it's just as important, if not more, probably more important, to help them with their thought process. Like if you get stuck, what do you do? And not to be dependent on the teacher for that, but they should have an internal monologue themselves. And so part of what I do, and I think it's just so essential, is to teach them how to go through that internal monologue themselves. Because I'm not going to be there for them all the time. They're going to get to an exam, be taking their SATs or whatever, and they're going to get to something they don't know. That's going to be inevitable. Okay, I see something. How do I think through it? What do I know? And so for me, when I'm giving a lesson, I'm really, as much as possible, I'm just asking them questions, guided questions, so they can do the thinking for themselves as much as possible. And then hopefully...
Do you have a format for that? Like, it sounds like you start with, okay, what do you know? Right?
Yeah.
And what are the other kind of questions that are there set questions, or is it always...
I think it really depends on who the student is and kind of what they need. But again, one of my favorite questions is, so what are you doing? So what have you been doing? So, because especially with materials, if like the checkerboard, that can become very rote. Kids just do it. They go through the process. They're not really thinking about what they're doing and why. And so, we need to ask them questions sometimes to have them analyze, okay, what are you doing? Why are you doing this? And then, so that's why I'll ask them, like, okay, so don't tell me what the answer is. Tell me what you're doing to get that answer. And then I'll ask them, well, what would happen if? Okay, so what would happen if, so there's no materials, there's nothing here. What would you do in this other situation? Getting them to use their imaginations. And to say, okay, I'm going to take what I just did, apply it to this new situation, and now they have a methodology. And that's what's really important, because, I mean, mathematical skills are great, but the truth is most people don't use, unless you're going to engineering or something like that, they're not going to be using this stuff. So what are we doing? Kids say, why do I have to learn this? I have to think, well, why am I teaching this? What am I doing?
Yeah.
And it is to prepare students for things if they want to go down a certain path, for sure. And I don't neglect that. But more importantly, for all of our students, it's really about mathematical thinking. Montessori talks about the mathematical mind. How do you think in a logical way? There's so many instances in life where we just have to think through something. We don't know the answer. We have to problem solve. We have to puzzle it out. And mathematics is just great training for that. It's training how to think. When you have something you don't know how to do, what do? You don't just give up. You have to kind of think through it. And so, I want kids to develop their own internal monologues. I can model it for them. And I do that, but really I want students to be their own critical thinkers. And if I can do that through mathematics and get them skills along the way, then that's great. But we use mathematical thinking all the time, even if we don't use it for mathematics. We use that kind of thinking. And so that's what I want to give all my students. And then, I also don't want them to be afraid of math. Like, I have kids come into high school sometimes, they're just like, they just hate math, and they have this barrier and this wall up there. And I've known friends of mine who have changed their majors in college because they had to take a math class. They want to be a psychologist, but they have to take a stats class. They're like, well, I can't do that because I'm so afraid. And so I know it's really amazing. So even if my students leave high school and they haven't taken advanced stats, or they didn't get through calculus or whatever, I want them to enjoy math. I want them to know that it's that it can be, I want to be interested, know that it's interesting. And I want them to not be afraid of it. Because, maybe their sophomore year in college, they might be interested in something and they can take a math class later on. You could always learn those skills later. That's how I did. I mean, I learned most of my math skills in college. I wasn't mature enough in high school, or I was just an adolescent, and I didn't. I liked math in a way, but not the way it was taught, and I wasn't good at it at all in high school. It wasn't until I matured later, and I was in college, that I started taking more math classes, and it's like, okay, I can actually do this.
I can't
So,
tell you how many people I've talked to who think they discovered that they actually loved math when they became Montessori guides
mhm,
and through the materials. And I have a friend who thought she was dumb in math her whole life. Like that was the voice in her head was she was dumb in math. She couldn't do it. And as soon as she became a Montessori teacher, she realized that she wasn't dumb in math. The way they approached it with her was dumb, and it didn't work. And so as soon as she got her hands on the materials, she had this awakening, and
mhm.
she's not the only one.
No, I've seen it all the time in my own training. I'm like,
Mhm.
oh my gosh, I finally understand why we do this for the first time ever. And people and adults can do the work, but they don't understand where it comes from or why. And it's so beautiful. And so, okay, so that's a good point, because especially for adolescents, like treating them more like adults, like if adults have that experience, a lot of times adolescents will have that same experience. Or if we treat them more like adults, like, hey, I know you know this, but let me show you this really cool way to see it.
Mhm.
Like they'll get that same kind of joy and excitement out of seeing the materials as well. So it's not, because I still want them to have that anchor in a material and something concrete. Um,
Mhm.
sometimes that comes, like I said, after they've already learned it. It's like, oh, this is really cool. Have you ever seen this before? It's like, oh, that's really neat how that works. I never knew why, or they knew why, but they forgot why. When you divide fractions, you do but when you see with the materials, it's so obvious and it's really beautiful. It's just genius. And I love it. And
That's
so,
great.
my job is, my goal has been to try to expand that for the adolescents, to say, okay, how can we keep that going?
Mhm.
And the approach has to be different than an elementary. Um,
That's what
it's
Dr. Montessori told us our job was.
yeah,
She said you're not filling them with all the facts. You
mhm,
are supposed to keep the light called intelligence lit, right? And that flame of excitement around learning lit. And
yeah,
I can tell you, if you had been my math teacher, now I also have to share that as you're sharing a lot of this, and I'm thinking, I don't know all those things. And I did pretty well in math, and I took college level math classes, not a lot. But I never got to calculus, and I would have loved to learn math this way. I always have enjoyed how math supports us as human beings and the thinking that it provides. And
mhm.
so I just really appreciate you taking time to help us understand our adolescents and our Upper L students better.
Well, my pleasure. Yeah, and that's kind of why I fell into it, is because I didn't understand it well, and it
Mm,
wasn't what. And and for my own sake, I took some math classes in college, undergraduate work, um, and I was poor, so I was working in the kitchen doing dishes for my college job. But then in my calculus class, which I never took calc in high school, but in college, they said if you have a certain grade in the class, then you can become a math tutor. And
mm,
so I became a math tutor in college, and it was basically just open time where, like, I'd sit in the lounge in a dorm, and kids would come in for a couple, for whatever hours, or and I'd help. And um and I had a couple private students too, but trying to figure out how to teach it to other people, you have
mm,
to really understand it. And
mhm,
so that's when, I was like, okay, in order for me to explain this, I have to really understand it. And so I figured out new ways of, like, I had moments while I was teaching somebody else of understanding what it was for the first time.
uh-huh.
um, and so, yeah, I mean, I just encourage everybody out there to, I mean, if you figure it out, once you figure it out for yourself,
Mhm,
it's just such a difference in your understanding. And I want to share that same thing with my students. And
mm,
so I don't want them to have to struggle the way I did.
right,
I wanted them to start off with that good feeling of, like, oh yeah, I figured this out on my own. And
right.
um, sometimes kids will, but the adolescents, they'll say, why don't you just tell us that? I'm like, because you need to discover it for yourself. You made us do all this, and you could have just said, this is the answer here. Like, I could have, but it wouldn't have meant the same thing to you. And they get frustrated with me sometimes because of that. But hopefully I'm giving them this great gift of that self-confidence, that understanding, the love of math. I mean, not only going to like love it's not going to be their favorite subject, but at least they don't hate it. They're not afraid of it.
Mm-hmm.
And they can appreciate it. I mean, I'm not an artist, but I can appreciate art. Kids might not be mathematicians, but they can appreciate it, and they know there's a use for it. They have an understanding. And if I can give them that, then I think I've done my job. So.
Well, I love that. And I agree. I think the fact that at least at our Montessori school, Greenspring Montessori, we don't hear this divide between boys and girls, liking math, not liking math, not liking science, not liking science. I love hearing that all the children, there, of course, there are some who that's not their favorite, or they love writing, or, those pieces, but it's not this significant divide in the culture where you can't be a girl and love math and science. We have so many girls and that love math, love science. And it's such a gift to the world to have people get to be who they came to the world to be and not be defined by these gender roles, which I know we're having breakthroughs in all over the place right now. And they're still skewed if you look at the educational numbers. So
yeah, no, that's so great to hear that you're observing that. And what's funny is that I don't know if it was at a conference or something, but I got that question about, what's the divide between the boys and girls, and I thought, like, I never even occurred to me, because I would see the same thing. It's like, half my advanced class or 3/4 of my advanced class was female. And, it's just like, I'm like, it just never really occurred to me. And people kind of like, well, come on. I'm like, no, it's like, I don't see Montessori just takes child for who they are, and it doesn't stereotype it or push it on one group or another. Yeah, so I've seen the same thing. I'm glad that you're seeing the same thing at your school. That's awesome.
I love it. It's part of another one of those beautiful pieces of Montessori. So we have to wrap up today, Mike. I am so grateful to have had you here today. I feel like everyone who listens to this is going to have an enhanced experience in mathematics and sharing it with students. And I really appreciate your practical tips for us on how do we do this such important work with our students. So thank you, thank you, thank you.
Oh, it's been my absolute pleasure. Thank you so much for having me. It's just great to share. This is what I love to do. And so I just really appreciate the opportunity. So thank you so much.
Well, and what I'm going to ask is, how do people get in touch with you if they want to know more about you? Or
great. Yeah. We have a website. It's www.themathinstitute.org. And you can contact me through there. And all our materials are up there. The books, the video lessons. Yeah, everything's there at the website. So themathinstitute.org, and you can find everything there. So thank you.
That's perfect. That's perfect, because as people start to build their own practice and want to dig in deeper, right? That's the work. And we as the guides, we as the Montessorians, our job is to also stay inspired and excited and learning, because that's how we model that for our students. So thank you for being a leader in that way. And thank you for being here. And
my pleasure.
Yeah, really a pleasure today. Really a pleasure. I knew it would be, but it was even better than I thought.
Well, I was nervous and I made it through, so I'm really happy. So thanks.
Hooray. To our listeners, we invite you to subscribe to our podcast to hear the latest episodes and to join in the conversation on Facebook and LinkedIn and Instagram. You can take a look at our website, greenspringcenter.org, to view the show notes for today's episodes. And I just want to say thank you so much, listeners, for spending time with us today. The work that you do is so important. I don't know of any work that is more important in our world and for our world. And we are so grateful for you. This is the Montessori Revolution. Join us next time.